Hi everyone, my name is Khanh and I'm a developer advocate at Google. Today, I'd like to introduce you to MediaPipe, a low-code, no-code framework to build and deploy on-device machine learning solutions across platforms. If you are interested in integrating machine learning into your mobile, web, or IoT applications in just a few lines of code, then this session is for you. I'll start with showing you what MediaPipe is and how you can use MediaPipe to integrate on-device machine learning into your applications in just a few lines of code. Then I'll wrap up with a sneak peek of our future plan, such as our exploration into on-device generative AI. Let's get started. So, what is on-device machine learning? On-device machine learning is a kind of machine learning that runs entirely on user devices, such as smartphones or web browsers, without sending user data to the server for processing. You probably have used some kind of on-device machine learning before. For example, many magical features in Google Pixel are powered by on-device machine learning, such as the magic eraser feature that allows you to erase photo bombers from your photos, or the live caption feature that transcribes audio playing on your phone in real time. On-device machine learning has been a difficult engineering problem. For example, let's take a look at a seemingly simple machine learning task, hand gesture recognition. It takes an image as the input and returns hand gestures found in the image. Here it detects a thumbs up gestures with 63% confidence. Although it seems simple, this task actually requires 4 different machine learning models chained together. The first one detects hands from the image. The second one detects the hand landmarks. The third one creates an embedding vector of the gestures. And the fourth one classifies this embedding as a thumbs up. On top of it, there are many other things that you need to take care of, such as how to run the whole pipeline efficiently on GPU, or how to deploy it on very different platforms such as Android and web. The good news is MediaPipe abstracts all of this complexity and offers you low-code and no-code tools to get started with on-device machine learning easily. We do that by focusing on a specific set of common machine learning use cases and provide easy-to-use on-device solutions for them. We have 14 solutions available today, and hand gesture recognition is one of them. MediaPipe is built on top of TensorFlow Lite, which is Google's official framework for on-device machine learning inference. Each solution in MediaPipe contains one or more TensorFlow Lite models, and MediaPipe provides a pipeline that chains the model together for you. The MediaPipe solution for hand gesture recognition has already done this pipelining work for you, so you don't need to worry about orchestrating all these models. You only need to interact with a simple API, fit the input image in, and get the prediction result out. Next, let me show you the MediaPipe API in more detail. To integrate the hand gesture recognition solution into your app, you will need to use a library called MediaPipe Task. This is the Kotlin code that you will need to write. The first step is to create a gesture recognizer object. You need to specify the model bundle that you want to use. This model bundle contains the 4 TensorFlow Lite models that are needed for this solution. Then you define the input image. Here I use an Android's bitmap object. And finally, you call the recognize function on the input image. Here's the recognition result object. You have a list of gesture objects, each representing a potential type of gesture found in the input image. And if you also have a web app that you need to integrate this solution, then no problem, you can do it very easily. This is the JavaScript code that you should add to your web app. It follows the same flow as in Android. Input image in, detected gesture out. Very easy, isn't it? You may wonder what are the platforms that MediaPipe currently supports. Well, we already have support for Android, web, and Python. iOS support is coming soon. And if you wonder what solutions we provide today other than hand gesture recognition, then you can check them out easily in MediaPipe Studio, and let me show you how. MediaPipe Studio is a web app. If you go there, you will find a playground where you can try out all on-device machine learning solutions from MediaPipe right in your web browser. Of course, you can try out the hand gesture recognition solutions in MediaPipe Studio. You can see that it can recognize thumbs up, thumbs down, or victory gestures in real time. This solution can recognize single hand gestures today. We're adding support for 2 hand gestures, and you will see them coming soon. Let's try another solution, image segmentation. MediaPipe offers multiple off-the-shelf models for this solution. One of them is a selfie segmentation model that can differentiate between a person and the background. It's a kind of model used in Google Meet to blur or change your background in video conferences. We are excited to announce a new segmentation solution that can segment more general objects that it hasn't seen during the training process. This solution takes an image and a point of interest as the input, then it gives you a segmentation mask that distinguishes the object at the point of interest from the rest of the image. For example, given this input image, you can click on the dog or the person to segment them in the image. Let me show you another one. Face landmark detection. This model can detect more than 400 different landmarks on your face. We are excited to announce a new feature in the face landmark detection solutions that gives you 52 blend shape scores representing different facial expressions such as open mouth or raising eyebrow. This technology helps you create virtual avatars that mimic humans' facial movement. You can find its demo and its source code in the video description. KDDI is a telecommunications company in Japan that wants to innovate the entertainment experience with XR and 5G. They are experimenting with this MediaPipe technology in their product. They use a local computer running MediaPipe to capture a human performer's facial expression and transfer it to a high-quality 3D virtual avatar in real time. Then it's combined with real-time pose detection to recreate the whole virtual performer in 3D. The performance is then live-streamed to viewers through Google Cloud. MediaPipe isn't limited to just computer vision domains. We also have text and audio solutions such as text classification or audio classification. Please go to MediaPipe Studio if you want to explore what kinds of magic you can create with on-device machine learning. In MediaPipe, we put a lot of effort in creating new on-device machine learning solutions that just work out of the box. However, we also know that in many cases, you need to customize the solutions to fit your own use cases. Let's take the hand gesture recognition solution as an example. The off-the-shelf model can recognize 7 different types of gestures, as I show here, but they don't include gestures like rock, paper, or scissors. So if you want to build an app to let users play the rock, paper, scissors game with a computer, then you will need a way to customize the hand gesture recognition solution. The good news is that you can easily do so with MediaPipe Model Maker. Many of you may find this product sounds familiar. Yes, you're right. MediaPipe Model Maker follows the same concept as TensorFlow Model Maker, but it was built entirely from scratch to be a low-code library to customize solutions provided by MediaPipe. Let me show you how to use Model Maker to create a custom hand gesture recognizer that can recognize rock, paper, and scissors gestures. You need to start with collecting a training dataset with hands showing rock, paper, and scissors gestures. Once you have the dataset, you can start using Model Maker to train a custom model to recognize these gestures. Model Maker is a Python library, so you can use Google Colab to train model faster using Colab's free GPUs. First, you need to import the gesture recognizer module. Then you load the rock, paper, scissors dataset and start training the custom model. After model training has finished, you can use the test dataset which the model hasn't seen during the training process to check the accuracy of the model. And finally, you can export it to deploy on-device using MediaPipe Task. You may wonder why the exported model has a .task extension but not .tf-lite. It is because its hand gesture recognition solutions requires multiple TensorFlow models, so this .task file is actually a bundle containing multiple TensorFlow models and some metadata. After you have your custom model bundle, you can upload it to MediaPipe Studio to try it out right away. You can see that the custom solutions can now recognize rock, paper, and scissors gestures. Deploying the new custom solutions on Android is very easy. You just need to replace the off-the-shelf model bundle with the new custom model bundle that you have just created using Model Maker. The rest of the code stays the same. We have made a rock, paper, scissors game as a web demo using this custom model. You can find the URL of the demo and its source code in the video description. Try it out and see if you can beat the computer. I hope the rock, paper, scissors example gave you an idea of how easy it is to build a custom on-device machine learning solutions using MediaPipe. Today, you need to write some Python code to create custom solutions, but we're working on adding a no-code customization tool into MediaPipe Studio. Soon, you will be able to upload your training data to Studio to create custom solutions without writing a single line of code. On top of the features that are already available today, we're actively working on some exciting new features that will push the limit of on-device machine learning. Generative AI has been a hot topic gaining significant interest since the end of last year. Today's generative AI models, such as Imagen or Lambda, are still gigantic, so they are not yet suitable to run on-device. However, we found that a technique called model distillation can be used to distill those general-purpose large models into smaller models that can run on-device and specialize on a certain number of tasks. We are excited to announce an experimental on-device solution that allows you to stylize faces in images. For example, you can use this solution to transform your photos into cartoon style. This solution supports customization, which means you can prepare a few style examples, such as anime faces, and use Model Maker to create a custom solution that can transfer any faces to this style. Please only use this solution on your face or faces of people who have given you permission to do so. Another generative AI model that we're running experiments with is diffusion-based image generation model. We were able to generate images from a text prompt on a higher-end Android phones within a few seconds. We're working on reducing the model size so that it's more suitable to be used in actual apps. Stay tuned for more updates. We're also doing experiments with on-device text generation solutions. We were able to deploy a large language model on Android that can help you do several tasks with natural languages, such as summing up a long conversation or writing a formal email from a given topic. On-device generative AI is in its early days, so there are still many technical challenges we need to overcome to make them ready for production. Stay tuned for our updates in the coming months. So there was a lot of content that we covered today. Before we wrap up, let's recap the most important topics. MediaPipe provides you off-the-shelf on-device machine learning solutions that you can easily integrate into your mobile or web apps in just a few lines of code. MediaPipe Studio allows you to try out these solutions right in your web browser so that you can come up with ideas about how on-device machine learning can be integrated into your apps. Many of these solutions can be customized using your own dataset, and MediaPipe Model Maker is a low-code Python library you can use to customize MediaPipe solutions. If you want to learn more about MediaPipe, check out our website at developers.google.com/MediaPipe. Thank you for watching, and don't forget to subscribe to our TensorFlow YouTube channel for more content about on-device machine learning.